So this is YouTube recording. It should be recording. I just want to talk about the relationship between low-pass filters and the Gaussian filter. The Gaussian filter is controlled by the standard deviation. With a larger standard deviation, then essentially you have a larger kernel and you're convoluting the smaller kernels so that you're blurring more of the photo. So you can see here that standard deviation of a standard deviation of this sigma size with this sigma kernel is related to a low-pass filter. I'm only drawing another side, like the positive side, so that you can see that this is only the positive side because the negative side doesn't really matter. But you can see that this low-pass filter is also normally distributed. So the standard deviation for the Gaussian blur is inversely proportional to the low-pass filter by the constant 1 over 2 pi. So that you can see that if we have a large Gaussian filter with a really large standard deviation, then we're going to have a very, very small cutoff line, which means that everything that has high frequency is going to be cut out, so the image will be very, very blurry, very, very blurry. Gaussian represents a optical blur. So if you have a Gaussian filter that has a very small standard deviation, so which means that the center is a lot higher than the rest, then your cutoff is going to be inversely proportional large, which means you let a lot of high frequency noises gets passed through, so then your image will not be blurred as much and noises will be passed through. So we have this relationship here. And that's sort of the relationship between a Gaussian filter and a low-pass filter. So they are the same thing, but now we just have another way to look at it in the frequency domain.